This is Roxann Hayes. I am a senior instructor at CU Denver's Civil Engineering Department. Today we're going to be discussing clear zones. The AASTO Roadside Design Guide is the reason for this meeting today. The current AASTO Roadside Design Guide is the 4th edition published in 2011. This document gives us guidance to help highway agencies develop our own standards for determining the widths of clear zones. These are based on speed, traffic, volume, roadside slope, and curvature. The AASTO Roadside Design Guide provides this diagram showing that up to 48% of fixed object fatalities are trees that are hit. Utility poles end up at 12% and they go down from there. A vehicle could leave the roadway and encroach upon this clear zone or the roadside for many different reasons, including driver fatigue, driver distractions or inattention, excessive speed, driving under the influence of drugs or alcohol, crash avoidance, adverse roadway conditions such as ice, snow, or rain, vehicle component failure, and/or poor visibility. These are some of the geometry features we'll be looking at today. The Roadside Design Guide defines this clear zone as the total roadside border area. This is starting at the edge of the traveled way and is available for safe use by errant vehicles. This area may consist of the following: a shoulder, a recoverable slope, a non-recoverable slope, and/or a clear runout area. Simply stated, the clear zone is an unobstructed, relatively flat area beyond the edge of the traveled way. This allows a driver to stop safely or regain control of a vehicle that has left the traveled way. The Roadside Design Guide states that the clear zone starts at the edge of the traveled way. The width of this clear zone is based on risk or exposure. All of the key factors in assessing this risk will include the traffic volumes, speeds, and/or slopes. Clear roadsides will consider not only fixed objects, but the terrain that may cause vehicles to roll over. By creating clear zones, roadway agencies can increase the likelihood that a roadway departure will result in a safe recovery rather than a crash, and will mitigate the severity of crashes that do occur. Horizontal clearance is not the same as clear zone. The horizontal clearance that's discussed in the AASTO Green Book is the minimum standard offset that allows for normal traffic conditions. Curbs do not necessarily deter errant vehicles from leaving the traveled way, so the minimum horizontal clearance does not necessarily provide a clear zone sufficient to accommodate errant vehicles. A minimum 18-inch horizontal clearance to vertical obstructions must still be met unless a design exception is approved. Horizontal clearance is basically the lateral offset distance from the edge of the traveled way to another designated point of a vertical roadside element. This lateral offset is really to provide clearance for mirrors on trucks and buses that are in the extreme right lane of a facility, and for opening curbside doors of parked vehicles, as two examples. Some of the roadside elements that will require horizontal clearance will include the following: curbs, walls, barriers, piers, sign and signal supports, mature trees, landscaped items, and power poles. A recoverable slope is a slope on which a motorist may, to a greater or lesser extent, retain or regain control of a vehicle by slowing or stopping. Slopes flatter than 1 vertical to 4 horizontal are generally considered recoverable. A non-recoverable slope is a slope where this is considered traversable, but on which an errant vehicle will continue to the bottom. Embankment slopes somewhere between 1 vertical to 3 horizontal and 1 vertical to 4 horizontal may be considered traversable but non-recoverable, but only if they are smooth and free of fixed objects. A clear runout area is the area at the toe of a non-recoverable slope that is available for safe use by an errant vehicle. Slopes that are steeper than 1 vertical to 3 horizontal are not considered traversable and are not considered part of the clear zone. Trees that are near the road that have obviously been struck before will deserve special attention. For urban environments, right-of-way is extremely limited, and in many cases, it is not practical to establish a clear zone using the guidance provided in the AASTO Roadside Design Guide. Urban environments are usually characterized by the sidewalks beginning at the face of the curb, enclosed drainage, numerous fixed objects such as signs, utility poles, luminaire supports, fire hydrants, sidewalk furniture, etc., as well as frequent traffic stops. Rural versus urban. Can we do anything in between? We do have areas called transition areas. These are curbed facilities that are in between rural and urban settings. There might be an opportunity to provide greater lateral offset in the location of the fixed objects. These facilities are generally characterized by higher operating speeds and have sidewalks separated from the curb by a grass strip. Let's look at some examples of clear zone issues. This is a guardrail that's really providing no protection, but in itself is a hazard. Here's a heavily wooded area that is close to the travel lane. Isolated trees in the lawn of an adjacent property may actually be a clear zone hazard in and of itself. Here's some examples of clear zone solutions as provided by the AASTO Roadside Design Guide. Let's look at an example problem of how we would actually determine the clear zone. This is from the AASTO Roadside Design Guide, 4th edition. We'll be using the US customary units. Some of the columns that we'll be looking at here will include the design speed, anywhere from less than 40 miles an hour up to 70 miles an hour. The design ADT, or average daily traffic, can then be input here to determine what our clear zone will be. We'll be using either the foreslope or the back slope, and with the determination of the actual slope involved. Here's the designation of roadside regions. Here we can see the foreslope will be on the area closest to the travel lane, and the back slope will be on the far side of that ditch bottom. The fill slope or the foreslope, back slope or the cut slope. Let's use this clear zone example problem. We have a 6-to-1 slope that's on the fill slope. The fill slope will be here on the area that is closest to the travel lane. We'll use a 60 mile per hour speed, and 5,000 vehicles per day will be your ADT. Let's start with our design speed. That was 60 miles an hour, so we're going to enter into this row here. We had a design ADT, or average daily traffic, of 5,000 vehicles per day. We'll go ahead and enter in here between 1,500 to 6,000 ADT. We know that we're using a foreslope. We also know that we had a 6 horizontal to 1 vertical slope. And you can see here your clear zone width will be anywhere from 26 to 30 feet. We'll go ahead and utilize the lesser number of 26 as our more conservative number.